demand curve. And above the equilibrium price. And up to the equilibrium quantity. Okay, so in our graph, the area below the demand curve, the red line is the demand curve, so the area below the demand curve and above the price, which is P equals to 30, and up to the equilibrium quantity, which is 150. So this is our consumer surplus. But for producer surplus, usually we define producer surplus as the area below the price, below the equilibrium price, and above the supply curve. And up to the equilibrium quantity. Okay. But in our case, it's a little bit tricky because unlike the common supply curve where we see is an upward sloping straight line, now it's a vertical line. So it's kind of difficult to tell which area is actually above the supply curve. So for such cases, I would recommend to first draw a supply curve that you're familiar with. So let's say this S prime, this is the supply curve that we're usually familiar with. And then we know that the area above the supply curve is actually to the left, to the upper left side of the supply curve, right? So if we want to find out producer surplus, in this case, where supply curve is S prime, it's actually easier for us to tell which direction we should look at. And it's quite similar to our case. So our case is like an extreme version. If we rotate our S prime to the vertical position, so we will know that when we look for the producer surplus, we should also look to the left-hand side of the supply curve to calculate producer surplus. So I will remove that hypothetical case. And now for us to find out the producer surplus, it should be the area below the price equals to 30 range, but to the left of the supply curve, and also up to Q equals to 150. And that gives us this rectangular area in black. Okay, so this is how producer surplus is represented in our graph. And next, talking about yeah, so this is all for consumer surplus and producer surplus. And if you want to calculate the area, it's also quite straightforward because we know this, for consumer surplus, we know this part is, I'll just use a yellow line. So for this part, it's 30, and for this part, it's 150. So it's easy to calculate consumer surplus, although it's not asked. If it is asked, if you're required to calculate the area for consumer surplus, that is just 1.5 times 30 times 150. Okay, and if you're asked to calculate producer surplus, that's the area of this rectangular, and that would be, we know this part is 150, and we know this vertical part is 30. So that producer surplus is actually 30 times 150. So it's also easy to calculate numerically. And then moving on to part E, on this graph, label the deadweight loss generated by a fixed price of $30, if there is any. So for part E, we need to find out the deadweight loss. The deadweight loss is just the loss in total surplus, and in our case, because the total surplus, so this is the change in total surplus. after setting P equals to 30. So we know that total surplus in our case is actually producer surplus plus consumer surplus. Usually we should also consider government, but here we do not see government playing any role, so we do not include the part for government and only include producer surplus plus consumer surplus. So before the price change, the equilibrium quantity is 200 and the equilibrium price is 20. So I just use the blue line to represent the scenario before the price change. So before the price change, equilibrium price is 20, and this will be the consumer surplus, 0, and this will be producer surplus, PS 0. But after the price change, we see that consumer surplus actually shrinked to this yellow triangle, and producer surplus actually shrinks to this yellow rectangular. So this trapezoid area in blue is just the shrinkage in total surplus after we set the price to be $30. So the deadweight loss is actually the blue area, the blue shaded area. And he's not asking you to calculate the region, but if he did ask you to calculate, we know that for the trapezoid, we need to know this part, the length is 20, and this part, the length is 30. And its height is just 200 minus 150, which gives us 50. So if you are actually asked to calculate the area of the deadweight loss, that will be 1/2 times 20 plus 30 times 150 times 50. And that will be the area of the deadweight loss. Okay. Any questions so far? If not, I'm moving on to part F. Part F, what is the parking lot owner's short-run marginal or economic cost per parking spot? We know that in the short run, the parking lot owner, he cannot do anything about this parking lot. He cannot rent it out. So in the short run, there is no variable cost. The quantity provided is fixed. There's no variable cost. And we know that marginal cost is just partial, it's just if the quantity increases by 1 unit, how much will the variable cost change? But since there is no variable cost, we know that the marginal cost is also 0. Okay. And for part G, what is the total short-run economic profit at the market clearing price? So to calculate the economic profit, we know that economic profit is should equal to revenue minus cost, or let's say revenue minus economic cost. So our question becomes, what is the economic cost in the short run? An economic cost, it should be the accounting cost. Minus fixed cost. Plus opportunity cost. And here, because in the short run, we say we don't have any information about the other parts. But as for opportunity cost, we say that in the short run, we can't do anything. The owner can't do anything about these lands. So the opportunity cost is 0. But in the long run, the owner is able to rent this land out. So the opportunity cost in the long run would be $10 per parking spot. And then for part G, because our horizon is still in the short run, that would be $0. So that means the economic profit in the short run it will be revenue minus economic cost. But this equals to 0 in the short run. So we only need to consider the revenue. So it's just revenue. And that would be the equilibrium price times equilibrium quantity in the short run, which is 20 times 200, and that gives us 4,000. And be careful, in the answer key, there's a typo. It only talks about the equilibrium price, but we should actually calculate the revenue and the profit. It's incorrect. So this should be the correct answer. So this is for part G. And moving on to part H. In part G, we're still in the short run time horizon. But in part H, the question becomes, what is the long run marginal economic cost per parking spot? When there are 200 spots, what are the total long run economic profits or losses? So as we talked about before, in the short run, the marginal economic cost is 0, but in the long run, since there is an opportunity cost, the opportunity cost, which is $10 per unit, so that is the long run marginal economic cost. So in the long run, because there is opportunity cost, since the owner can rent spots out at $10 per spot, this will be the marginal cost. Because this is opportunity cost. In the long run. Here, LR is just a short form for long run. And if there are 200 spots, the long run profit, the economic profit, it will be revenue minus economic cost. And we already said that the equilibrium price is 20 and the equilibrium quantity is 200, so that is the revenue. Okay, this is equilibrium price, and this is the equilibrium quantity. And the economic cost, because we say that the opportunity cost is $10 per unit, so that would be $10 per units times the total Q star available. And this $10 is just the opportunity cost. So plugging in all these numbers, you can calculate the economic profit in the long run is $2,000. And obviously, this is a positive number. The long run economic profit is greater than 0. And as we said in class, if the long run profit is positive, then more people are willing to be the supplier. So more people will choose to enter. And that is, let's say, for part H, we had a positive profit, and then for part I, it asks, in the long run, will there be an increase, that means an entry, or decrease in supply, that means there's exit, or there's no change in the number of parking spaces in the city from the baseline of 200 units. So if because we say that the long run profit is 2,000, which is greater than 0, that means it's profitable. That's why more people will choose to enter the market. Since it's profitable. So far this is answer to this question, but I want to further explain what will happen afterwards. If more people choose to enter, that means if there are more suppliers, the supply curve will shift. And since there is more supply, but the demand is fixed, that means the equilibrium price will be driven down. Drive equilibrium price down. And if equilibrium price is further driven down, that means the profit will drop. And as profit continues to drop, entrance will finally stop when profit drops to 0. Okay? And that will be the hint to answer to part J. Part J asks, what is the long run price that clears the parking market? How many parking spaces will there be in the long run? And call these values P. I'll just call them PL star and QL star to differ from the short run equilibrium price and equilibrium quantity. So for part J, I'll just use pi as a short form for profit. We know that the profit would be equilibrium price minus the long run marginal cost, which is $10 as opportunity cost. Okay, so in the long run, the PL star and the QL star, such that at the equilibrium price is 0, so that no firm will choose to continue to enter. So if we want the long run profit to be 0, that means the long run PL star minus 10 should be 0. And that brings PL star equals to 10. So that is the equilibrium price in the long run. And plugging this into the demand function, we know that the equilibrium quantity in the long run is actually 300 minus 5 times long-term equilibrium price. So that is 300 minus 50, which is 250. So that's the answer to part J. In the long run, the equilibrium price will be 10, and the equilibrium quantity will be 250. And the key is, in the long run, at the equilibrium, the profit should be 0. Otherwise, if the profit is greater than 0, then more people will choose to enter. And if the profit is lower than 0, then the firms will choose to exit. So if it's not 0, then that is not an equilibrium scenario. So we would just choose P equals to the marginal cost, which is 10. So that's the answer for part J. Then moving on to part K. Suppose the number of parking space is Q star, so that market price is P star. If the government imposes a parking tax of $5, what will be the short-run effect on the equilibrium, and what will be the price paid by drivers, the price earned by parking lot owners, and the number of parking spaces used? So for part J, when we talk about tax, first we should think about who is actually bearing this tax. So immediately after the tax, the tax incidence depends on the relative elasticities of both parties. So for the supplier, here I use S for supplier. It's the negative of demand elasticity divided by demand elasticity plus supplier elasticity. And the share of tax borne by consumers is the negative of epsilon S, the supply elasticity, divided by the sum of supply elasticity plus demand elasticity. Okay, so these two equations are the general rules. And next, for our case, if we go back to our demand curve and supply curve, in our case, since quantity supplied is a fixed number, that means no matter how price changes, the quantity will not change. And the way we define supply elasticity is if there is a 1% change in product prices, how many percentage changes will we expect to see in the quantity supplied? Okay, and by our description, if QS is a fixed number, that means no matter how price changes, the change in quantity supplied will be 0. So that means epsilon S is 0. When there is a vertical or fixed supply curve, epsilon S equals to 0. That means supply is perfectly inelastic. Inelastic. Okay, so this is why we say epsilon S is equal to 0. Then coming back to what we're left with, so if epsilon S equals to 0, this is what we see in our graph, then that means the share of tax that consumer are going to pay is 0. So that means supplier is paying all tax. And here is the $5 per unit. And a general comment is the party that is less elastic bears more tax. Or say the party that is less flexible bears more tax. And in our case, because supplier is perfectly inelastic, that means supplier will bear all the tax, which is $5. So how can I clear it? I can't add more. So I'll just I'll just wipe out what I have. So continuing this, because the supplier is bearing all the tax and the consumer doesn't need to pay any tax, we say that so the consumers pay the original equilibrium price in the long run, which is $10, but the suppliers, they just bear the tax and need to deduct that amount of tax from what they earn. So it's 10 minus 5, which gives us $5. And the quantity demanded will be still be determined by the consumers. That is 300 minus 5 times PD, which is 250. So immediately after the tax, this is how the equilibrium results would be. The consumers pay $10, but the suppliers, they pay all the tax, so they can only earn $5 per spot, and the quantity is just 250. Then moving on to part L, what is the effect of the $5 parking tax in the long run, and what is the effect on the prices paid by drivers, the price earned by parking lot owners, and the number of parking spaces being used? So for part L, in the long run, because everything for the supplier will be flexible, for the supplier, the inputs for supplier will be perfectly flexible, and the inputs and also production for suppliers will be perfectly flexible. Then that means supply is perfectly elastic. So if you recall the incidence, the tax incidence, let's say for the consumers, it's incident D because it refers to the demand. We say it's negative of epsilon s divided by epsilon D plus epsilon s. So in the long run, after the tax, because the supplier will be perfectly elastic, we know that absolute value epsilon s will go to infinity. So if we take the limit of this whole thing as epsilon s goes to infinity, we see that it's a negative number of something going to the infinity. Is that this number? Yeah, let's look at epsilon s. So for the supplier, their tax incidence will be epsilon d divided by this times this. So the limit of incidence s will be limit of this goes to infinity of this thing, epsilon d plus epsilon s. And as this goes to infinitely large, the denominator becomes infinitely large, but the numerator is some fixed number. So we would know that this ratio would converge to 0. Okay, so the limit of this thing, if it goes to 0, then that means in the long run, because this is the tax, the share of tax borne by suppliers, in the long run, supplier, they won't bear any tax. So that means the consumers they will bear all the tax. And if the consumer is going to bear all the tax and the supplier won't bear any tax, that means in the long run, suppliers, they actually, in addition to that $10, they're paying the tax. So that brings their payment up to $15. But for suppliers, since they're not bearing any tax, they will just earn that $10. And the quantity will be the quantity demanded, where we plug in P equals to 15 to the demand curve. So it's $300 minus 5 times the price that consumers pay. And that would be $300 minus 15 times 5, and that would be 225. So in the long run, after the tax is imposed, the equilibrium quantity will become 225 units. So the difference between part K and part L is who is bearing all the tax. In the short run, because in our case, in our setup, producer is perfectly inelastic. So in the short run, producer will bear all the tax and consumer doesn't need to pay any tax. But in the long run, because producer becomes perfectly elastic, that means they won't need to bear any tax. And that means in the long run, consumer has to bear all the tax. And that leads to the difference in the prices consumer needs to pay and the prices that suppliers receive in the short run and in the long run. So if you don't have any questions, today's session is over. Thank you, and good luck to the final. And also for this week, I will be holding office hour tomorrow from 10 to 12 online like this. And also Roger, he will be holding his office hour on Friday I think in the office, unless he sends other notifications. So for me, like my office hour will be also in this form. You can just let me know your questions and I will write down and share my screen with you. Yeah, so good luck and take care. Bye-bye.